C works. D doesn't work. And E does work.
I agree. This is the kind of stuff you'll see on standardized tests. You got to know the difference between one solution, no solution, infinite solutions. Any questions of that before we move to 47?
Nope.
Okay. All right, here we go. 47. A contingency table, and sometimes this is called a two-way table. You'll see that notation sometimes in these problems. Another thing is that sometimes they only give you the table without the totals, and you almost always need the totals. So if they don't give you the totals, you have to find the totals. What is the probability that a student selected at random is a female given? So that's very important. Given, actually, let me just do that. Given that the student is not a senior. So whenever you see the word given, the given means that you are either looking at a row or a column. And it's based on the part after the given.
Okay.
All right. So in this example, there's only two possibilities, junior or senior. So if you're a senior, you're a senior. But if you're not a senior, you are a junior.
Okay.
So you are limited. Your focus is now just on this column. That's your world. Your whole world is that column. So if I could, I would use my hand and I would cover up this other stuff, but I can't. You have to just look at this column here. What is the probability that a student selected from random is a female? How many females are in this column?
15.
Females.
Oh, 6.
6. Out of how many total?
15.
Yes. All right, so let me grab this table and give you another problem here. There's not really much work. I'll type this one out. What is the probability that the student is a junior given that the student is not a female?
3/5 or 60%.
What two numbers are you using?
9 and 15.
Okay, this time it says given that the student is not a female. That's really important here. Not a female means you're in the male row.
Yep. The student is a junior, so it'd be
So how many juniors are there that are males?
9.
Out of how many in that row? Like your world is just this row. What that given is just that.
Oh, 16.
Right. So the way to think about this given is like sometimes we're given these scenarios in real life. It's like, we'll take you to, pick your favorite restaurant, A, B, and C, but that's it. Like we're not allowed to look outside of that. So this given it restricts you to a row or a column.
Okay.
Let me do one more here. Do we need to get through all this, or is this just sort of just something to look at?
No, it's just review.
Okay, so let me spend a little more time on this. All right, so this problem, they give you some sort of information: car, truck, total, male, female. What they do not give you is a total here, and you want not only the column totals, you want what I call the super total down here. Can you give me those, please?
So then, total for car is um, 80.
Good.
The total for
Truck.
truck is 70.
Now here, the super total should work when you go either horizontally or vertically, meaning it should be exactly the same.
It does. 150.
Okay, so let's try this again. What, oops, see if I can get my cursor. What is the probability that a male, or okay, what is the probability of preferring a car given that the person is not a male?
So female preferring a car is 35 out of 65.
Good. Let's try another one here. Let's be our last one of these. What is the probability the person is male given that they do not own a truck?
You can't own a truck. That's 45 over 45 over 80.
Yeah. All right. Good. Really good. So now let's go back to, and these are really, oh, wow. So this question here comes from 48 here comes from a statistics class. I mean, this is something you've probably not even seen before. It says a car dealership polled customers on the preferred type of vehicle, car, truck, and recorded results here. Is there an association between type of preferred vehicle and gender? It's kind of a vague question for you. Let's just look at the answers here. 53% of all customers preferred cars. Okay, so that was the 80 out of 150. Are you allowed to use a calculator on this or not?
Yes.
Okay, let me just check that actually is. Okay, that's true. And 47% preferred trucks. So the percentages are roughly the same. That means they're the same, like whether they like cars or truck. 53% of men preferred cars. Okay, so so this is letter B now. That's 45 out of 85. And we don't know what that percentage is. And 47% preferred trucks. The percentages for women are roughly the same. I'm not sure that's true. So you do have to do some of these calculations. So what I think this is getting at here, and I'm gonna have you do this here, is you have to calculate these percentages. Like 45 out of, well, maybe I'm probably digging too deep into this. All right, let's do a different problem because I'm not sure this is going to be useful to get into, because it's very very much based on like the way the answers are written, and I could just tell you maybe don't have the energy for that right now. So let's try a more numerical problem. Say,
Okay.
take a look at this. For $1,200, a business can post an advertisement for 30 days. For $1,500, the advertisement will be posted for 60 days. Okay, so there's some sort of an input X and an output Y, And they actually tell you that the cost is the output and the number of days is X. Okay. So that allows you to convert these two numbers, 1230, into an ordered pair, 1560 into an ordered pair. So it's like 30 days, 1200,
Okay.
60 days, 1500. Notice the answers are 4 equations. They all have different slopes. So that's a test taking strategy. Like what's different? What's the same about them? So if you can calculate the slope correctly, you have your answer. How do you
Okay.
calculate the slope from these data points?
So 1500 minus 1300
1200.
or minus 1200 over 30. And it's 300 over 30, which is 10x, and then C.
So it's probably C. Okay, but let's go a little bit further here. Y equals 10x plus B. How do you find B given this information? Like, let's say there was another answer here that was, 10x.
Plug in the point and
Okay,
see which one.
so let's try the first one here. 1200 equals 10 times 30 plus B. Okay, so 1200 equals 300 plus B. B is 900. Yes, it works. Another way to do this, and I don't recommend this, but another way to do a problem like this, especially if you had infinite time, is you could test the answers. Okay. What might be the problem with testing the answers in something like this?
Takes a long time.
It takes a long time, and you have to test both points because you may find that the first one works here, but you have to try both points in each one. So generally you don't try the answers unless you're stuck and have infinite time, which is probably not the case. All right. The diameter of the sun is approximately 1,400,000 kilometers, while the diameter of Saturn is approximately 1.2 times 10 to the 5th kilometers. How many kilometers larger is the diameter of the sun than the diameter of Saturn? Do you ever wonder how they measure the distances of things like this that are really far away?
Sometimes.
And you ever wonder how they get the mass of objects that we can't actually weigh? Like we know the mass of the Earth, we being, science community. Does that at all bother you, or does that amazing? I mean, what do you think of that?
I thought they just did the volume formula thingy.
So you can do it for volume, but again, it's like how do we know? Like we can't measure it, we can't it's not as simple as just here's a tape measure, let's go out there. Um, it's kind of amazing, and some of these numbers have been known for a few hundred years, so it's kind of impressive. Could you convert 1,400,000 into a scientific notation number for me, please?
I just converted 1.2 times 10 to the 5th into non-scientific.
So because the answers are all in scientific notation, you want to convert this one to scientific notation. The way you're doing it will work, but you're adding a little bit of extra, and you eventually have to go back anyway.
I got for my final answer 1.16 6 repeating times 10 to the 2.
Okay, let's take a look here. Whenever it's the one that's bigger goes in the numerator. So the sun is 1.4 times 10 to the 6th. Do you have that?
Yep.
Over 1.2 times 10 to the fifth. Do you have that?
Mm-hmm.
Okay. So 1.4 over 1.2. I'm kind of like wondering why these answers are here. This doesn't quite seem right. Yeah, 1.17. What am I missing here? So yeah, so the answer is, and the 10 to the 6 becomes 10 to the 1. This, do you have the answers here? Because there seems to be an error in this.
No, I don't have the answer key.
Diameter of the sun. The diameter of the sun is approximately kilometers, approximately. How many kilometers? Oh, I'm sorry. Larger. Larger means we're subtracting the two. So
Oh.
not dividing. That's why this is, so you were actually, that was a better strategy to go out to, so this is 1, 2, 0, like that. And you're just subtracting. That's how they're doing this. I'm like, man, how is this even possible? So if you haven't done this in a while, you just go and then maybe you borrow from the 4, 3, 1, 8, 1, 2, 8. So you're either 1, 2, 8, 10 to the 6th, 1, 2, 8, 10 to the 7th.
Um. Times 10 to the 6th. A.
Yes, very good. So I was reading the word kilometer, how many times larger is what I kept reading, but it's not that. It's just literally the difference between them. Any questions on that?
Nope.
All right. All right. Determine if each of the following equations has one rational solution or two. Rational just means here things like it has to be either a whole number, fraction, integer, but there's nothing like in the complex domain. All right, so this first one here, x squared equals 1. First one we're looking at here. Sometimes you got to go back to remind yourself what x squared is. It's a parabola, and the line 1, how many times does it hit that graph?
Twice.
Twice, yeah. Now, can you tell me the two answers?
Uh, it could be anything because we don't know X.
Right, but if you square x, if you square that whatever it is, you get 1. So it's basically saying a number times itself gets you back to 1.
Okay.
So what could you think of a number that when you multiply by itself you get 1?
Um, 1.
1. Okay. And there's one more.
-1.
Very good. All right, so let's look at the next one here. X cubed equals 8. You have not studied this yet, but a cubic function looks like this. Here's 8. How many times do they intersect?
Once.
Just once. What number is it? What number, when you multiply by itself 3 times, gets you to 8?
2.
2. All right. What do you think about x squared equals 0?
Isn't that one solution? Because only 0 squared is 0, so it only hit the
So you're
graph
correct.
in
Like,
one spot.
yeah, it hits just in one spot. All right. But there's this thing called the fundamental theorem of algebra, which says that the degree of the polynomial, which in this case is 2, tells you the number of solutions. So the answer is kind of both. It's 0 is what's called a repeated root. So how to answer this? I'd probably go with 1, but I actually could see justifying 2, especially if you said repeated root on there. How about the next one there, x squared equals 16? What do you think about that one?
Gonna hit it twice because it's gonna be -4 and 4.
Very good. Nice. So notice there's a pattern here. The ones that are even, or towers of 2, have 2 solutions. The ones that are odd, which we're about to see here again, they have 1 solution. That might be something of interest. Like if it's an odd power, in this case, it only has 1 solution. What number, when you multiply 3 times, gets you to 27? Forget about the fraction for a moment.
9.
9 times 9 times 9 is 729. 3 times. So what I think you meant was
3.
3. Yeah, you meant 9 times 3. Yeah, it's 3. 3 on the bottom, 1 on the top. All right. Any questions on that?
Nope.
Okay. All right, so for problem like 52, I think it's a good idea here. Let me snip it in. It's a good idea to describe the transformations to yourself before you go to the answers. I know the tendency is to go look at the answers and find it, but it's like better to kind of like be like, well, what's going on here? You have not studied this yet, so this is kind of beyond where you're at in math, but visually, I think you can tell a couple of things here. So there's what are called shifts, left and right. There are reflections, which it's generally over like a horizontal or vertical. There are enlargements or reductions. There are others, but this will be sufficient for us. Do you see any of this here?
A reflection and an enlargement and possibly a shift.
Possibly shift, yeah. So the way to do this is to actually make a table of the points, t and t prime. So give me the ordered pair of t and t prime.
T is 2, 2, and T prime is 4, 4.
4, -4.
Yeah, so then probably not a shift. Probably just a
It looks like
dilation.
it looks like a dilation, which is the enlargement. Yeah, that's the key. That's the word. I didn't know if you'd seen that before. Right. Okay. So now, and there's actually more here. There are rotations. I mean, there's a lot of things. So when you look at the answers, like what we had just done should help you kind of map, to answer here. So we got to be careful here. It is a reflection for sure. Okay, so like what I'm noticing is that only letter A has a reflection. The reason it's a reflection is because T and T prime are kind of right near each other. Same with S and S prime. A rotation would kind of cause this thing to hang down.
Yeah.
So
Unless it was like 180 degrees, but then T and T prime would be opposites.
right. So the rotations move 1 quadrant. If it's 180, it's 2 quadrants. So I mean, without really doing this, I'm pretty sure it's A. It does look like a dilation like we talked about, but a couple of these had dilations in it. So Another way to kind of look through these multiple choice is, what's the same, what's different.
Okay.
All right. Let's do 54 before we go to 53 because it's more like one we did earlier.
Okay.
All right. Go ahead and let me know which one for each.
Okay, so for the first one is infinitely many solutions. The second one is one solution. Wait.
Okay. What is the solution?
0. So it's no solution because 0 doesn't equal 3.
Good. Good. So that's what you should think. If it's got one solution, you should actually find it to make sure that it actually does have one.
And then for the last one is no solution.
Okay. What about the middle one?
It has one solution.
Okay. What is the solution to that one?
Track 3 and -6. So -3. So 3x equals x equals -2.
Good. All right. Let's quickly talk about rational and irrational and maybe some other things. Actually, let's back up here. The whole numbers, maybe you already know this. I'm sorry. Let's start with this. The natural numbers, they start at 1 and go up from there.
Okay.
The whole numbers add 0. The integers start at infinity, -3, -2, -1, 0, 1, 2, 3. So notice the relationship between them. The naturals, or the whole numbers, include all the naturals, but they add in 0. The integers add in the negatives of the naturals and then also include 0. So graphically, if this is the natural and ends the letter for natural, the whole numbers include the naturals and the integers include the whole numbers and the naturals. Have you seen that before?
Yeah.
Okay. And then the rational numbers, they include all of these. So you're looking for either written as a fraction or a repeated decimal or a terminating decimal.
Okay.
But sometimes these are disguised. Okay. Like the square root of 9 is rational because it's 3. So you always have to simplify. You always have to simplify. Something like the square root of 6 times the square root of, the square root of 9 times the square root of 4, which that's a bad example. Sorry. Let's say it's the square root of 12 times the square root of 3. This is the square root of 36, which is 6. So you have to be very careful there. So those are all the rationals. The irrationals, okay, they're kind of off to the side here, and that makes the real numbers. This whole thing is the real numbers. So it's good to kind of have that picture. If you really like math and set theory and stuff like this, there's whole courses on axioms of this stuff that I guess are pretty interesting. Okay, so again, you need to simplify before you tell me whether it's rational or irrational. Like you can't just look at it and be like, oh, it's rational or irrational. You got to simplify. Like this is really square root of 7 plus 3.
Okay.
Because the square root of 7 is irrational, the whole thing is irrational.
Okay.
Square root of 8 times the square root of 8, what does that simplify to?
Square root of 64.
Which equals 8. And that's good.
Yeah.
How about the next one there? What do you say?
10 plus 1, so rational.
Good.
Irrational.
Good. All right. Yeah, so I mean, a few other ways they can, I mean, sometimes they give you fractions. You know, they'll list them as decimals, like 0.1127, like that, and that's rational.
Yep.
But if it's a sequence we don't know, right, that's irrational.
Yep.
All right, very good. Okay, let's go back and do number 53. Charlie and Susan are planning a party for 10 people. Charlie finds a location that charges an initial fee of $20 plus 25 per person. What would the equation for that look like?
Y equals 25x plus 25. Or, 25x plus 20.
Good. And Susan finds a location whose rental fee is represented by the equation y equals 15x plus 100. All right. So that's Charlie, that's Susan. Okay. Graphically, one starts at 20 and goes up. Another one starts at 100 and also goes up, and they intersect somewhere.
Yep.
So we have to go through these and figure out, you know, which is true or false. The first one, Charlie's location, is a cheaper location. It's cheaper under certain conditions, but not always true. So it has to be always true. So that one's out. Is Susan's location cheaper for 10 people? Basically, is which equation is better for 10? Is it Susan or Charlie?
Times 225. That's 245. Susan.
Yes. So that is true. We're looking good there. The charge for each additional person is greater for Susan's location. So the additional person, that's the slope. Basically, which has the greater slope?
Charlie's.
Charlie. Okay. Now, when you see answers where they're basically the same except for one word or they flip things, you're typically choosing between them. Since this is a check the box problem, that might not always be true. If the number of people at the party changes to 12, the total cost of each location is the same. You can calculate it by putting 12 in, or you can set the equations equal.
Calculator. 25 times 12 plus so 320 and no, that's not true.
Whose is cheaper?
Charlie's.
Charlie's 320.
Or no,
Susan
sorry,
is
220.
180. Yeah, 180. All right, good. Okay, we're almost there. I know you can tell you're tired. I'll talk to Mom. Maybe we can get you in on an earlier time on another day. But let's see here. Box A contains the numbers 1, 2, 3, and 4. So this is right here, box A. And box B contains the numbers 5, 6, 7. So it's kind of like each of these, and 8, sorry. Each of these over here is box B. Because the idea is like A is step 1, B is step 2. How many outcomes are possible if both numbers are even? So basically, you got to look at the paths here and decide how can I get to an even number on both cases.
Both numbers are even. So if like 2 and 4, so if A and B were even?
They have to both be even. So like for example, 2 and 4
Or
is good.
like count how many even responses we have.
You want to count. So you're looking for the events that satisfy this criteria, and that's one of them. So how many events are there that satisfy this criteria?
2 and 4, and then 6 and 8.
What about 2 and 6?
Oh, 2, 6, and then 2, 8.
So 2, 8 and 2, 6. Okay. And then 4.
4, 6, and then 4, 8.
Yes.
So that's 4, right? So C.
Yes. All right. Good job. All right. The graph shows Amy's water use in gallons, the function number of minutes used. So what is the input? What is the output in this problem?
The input is
The input is always X. The output is
yeah.
always Y.
So the input is the amount of time.
That's right.
The output is the water used.
Yes. And notice it's steady, and then it's not as steep. Like it's got one slope for a while, and then think of that as like maybe you have the
So
faucet
it's
on.
used it for more than 21 minutes.
Yeah. Find Amy's
We
water
put
use.
it less than 21 minutes. It's
Yes.
at 6 and 10, so 6 divided by 10. So then 60 or 10 gallon or 0.6 gallons per minute for
What's
less than 21 minutes.
how did you come up with that? What numbers are you using? I'm not saying you're wrong. I'm just asking you, how did you come up with that?
It's 21, so 21 and 35. So then after 21,
So just look before 21. That's all we care about
slope
for
is
them.
0.6 per minute.
Okay.
0.6x, I think.
So just remember, slope is your rise. How much up are you going over your run? So notice your rise is
So
35 and
21
you're,
divided by 35.
well, it's rise over run. You're going up first, then your run.
Oh, rise over run.
Yes.
Okay.
And you can do the
So
same
then
thing for the next
it
one.
would
Like
be
you can use rise and run here for the next one.
so 1 point or 1 2/3. So the slope is 1 2/3
Sure. Yeah.
or
How about for the blue one here?
5/3. 5/3 x.
How did you come up with that for the next one? What's your rise and what's your run? What's the rise here?
And then for the second half would be and then I have to find so then 30. Wait, so that's plus 3, so 33, and then 45. So 45 by 33.
So just how
I
much is it
got
going up?
1.36.
Okay, but its rise is 10. Do you see it's going from 35 to 45?
Yeah.
And the run is 33 minus 21, which is 12. I feel like maybe we're not looking at the same graph, but just whenever you're given a coordinate plane, just draw the triangle.
So goes from 35 to 45, so that's 10. Oh, I get it now. Okay.
All right. Okay, real quickly here. I don't know if we'll have time to do all of 58, but let's have you at least calculate the slope. Let me grab this snipped in. Okay, find the equation of the line that goes through 4, 9, and 3, 2. Can you give me the slope first? Let's do that.
4, 9, and 3, 2. So that's 2 minus 9 over 3 minus 4. So then it's negative 7 over negative 1. So then 7. Yeah, so y equals 7x plus b.
Okay, use one of the points and find the b value, please.
9 equals 14 plus b.
Nope, no,
So
no,
then
9, hang on, 9 equals 7
9
times 4,
equals.
not 14. You use the,
Oh, yeah, it's 4.
yes,
So then b equals 19, negative 19.
good.
So then
Or
y equals 7x minus 19.
very good, awesome.